This is a demonstration that's going to illustrate many different concepts. Chemical versus physical changes, also compounds versus mixtures versus elements. So what we have here is steel wool. Steel wool is a tough material. Its job is to work as an abrasive, so we use it to rub things off. Steel wool is not made of wool. There's no wool involved. It's just been spun like you would spin wool. Alright, so it is steel. Now what is steel? Steel is actually a mixture of iron and carbon. Because iron is not very tough, they embed carbon atoms through the process of smelting. They embed carbon atoms in between the iron atoms. Now the iron and the carbon do not bond. This is just a physical change where iron is accompanied now with the carbon that's beside it. It just fills in the holes between the iron atoms. Now what happens is that interferes with the way that the iron atoms are going to bond to other iron atoms, making iron lock in place, making iron much more durable and tougher. So steel is tougher than iron. Okay? Steel is what these rods are made up of. So they're very tough, and as you can see, they don't catch on fire. The steel wool, made up of the same stuff that these rods are. Because this is a mixture and not a compound, steel, the iron part of steel, is going to retain its own characteristics. And one of those characteristics is its magnetism. So steel is still magnetic. As you can see, it's attracted. Alright, so the iron in the steel wool is still working like iron. It's magnetic. So, as we have seen, steel does not burn. Let's hit the lights there. So, steel doesn't burn, right? Or does it? Now notice a couple of things. First of all, there is a change in color. That does not necessarily mean that a chemical change has occurred, because color is a physical property. But there's a definite change in color. Whereas steel wool is really tough, this material now is very soft and brittle. Whereas steel wool is, of course, magnetic, this material is no longer magnetic. So, some definite property changes. What actually happened? Well, in this case, the iron reacted with the oxygen to produce a compound called iron 3 oxide. Now, this is not rust, but if you were to allow it to be exposed to water, it would then convert into iron 3 hydroxide, and you'll learn pretty soon what hydroxide means, but it will turn into that reddish, rusty color, and that is rust. So what happened here is that the iron reacted with the oxygen in the air to produce a type of rust, iron 3 oxide. An oxide. This is a new material. In this case, a change in color is evidence of a new thing being formed. Notice that the iron is no longer magnetic. That's because now that it is a compound, it has new properties that we must take into consideration. So the properties, both chemical and physical properties, of a compound usually are radically different from the chemical and physical properties of the elements that make up that compound. Oxygen is a gas. It's no longer a gas. Iron is tough and magnetic. No longer tough or magnetic. A new material has formed. Now, the reason why this steel rod did not combust is quite simple. This is on the surface. Remember that in order for this reaction to occur, the iron has to be in contact with oxygen. So when we first received this rod, it was nice and shiny. Over time, the iron has reacted with the oxygen on the surface so that this can be found on the surface of the rod. I can't light it anymore because the iron is no longer exposed to the oxygen and it can no longer react. So what would happen if we were to take this iron rod and shred it? Would it work then?